An attendee in listen-only mode.
Is done in due time.
Okay. We are looking forward to your presentation later on. Thank you, Christian. So my colleague Nico Strauch, please.
Hello, everyone. My name is Nico Strauch, and I'm responsible for public relations and for international markets at the VDMA Textile Machinery Association, and I will be the moderator of the Q&A session in this webinar later. I'm looking forward.
Yes, thank you. And I'd like to add that you can send your questions via the chat function during the whole webinar, and Nico will have a look on your questions, and then at the end of the webinar, we will answer the questions, or if not possible, then afterwards. So now, last but not least, my colleague Christine, please introduce yourself.
We can't hear you.
Your microphone, Christine.
Thank you for this advice. Hello, everybody, and thank you, Boris. My name is Christine Karin Schmidt. I'm the Technical Director of VDMA Textile Machinery Association. I'm responsible for all technical matters in our branch, and sourcing service is one of these topics. Thank you.
Thank you. Okay. Now, let's jump directly into our agenda. Now, Ingo Mehlmann from Oerlikon Nonwoven will present us his technology. So, Barbara, can you switch now the camera to Ingo, please?
Yeah, already done.
And now you can hear me as well?
Yes, we can.
You can see the slides, yeah?
Yes, perfect.
Perfect, good. Yes, welcome everybody. Thank you very much for this opportunity to present our melt-blown technology, which we are luckily now presenting and selling quite a lot at the moment to many customers all over the world to produce filter media to mostly be introduced into face masks. Yeah, let me start. This is the line we are selling as our so-called standard line for the melt-blown media production, which is actually a normal filter media production melt-blown line. Yeah, to my person itself, you have the contract details here on the slide, and I have this on the last slide as well for you to take into your notes and to contact me either afterwards via VDMA or directly. So whatever you prefer. So let us start with our melt-blown technology and what is what makes our technology unique and different from others. We always taking care about uniformity and precise tooling, precise manufacturing of the components, of the key components, to ensure uniform fluid and air management, which is one key component to produce these high-end medias. We do have an accelerated quenching, which allows the encapsulation of the process to make it more and more independent from the environment around the machine itself. We do have a uniform exhaust management, which allows the fiber laydown very evenly and across the width of the line. And we can produce with our technology very fine fibers, but at a quite high throughput, at a quite high capacity. So it's always the balance you have to take into account. Either you're going to very fine fibers, and then the productivity is going down, or you're going to more coarse fibers, and then the productivity can go up, but you're probably losing characteristics like filtration efficiency, which is a key factor for these kind of products. Our technology is very well known as a very versatile technology in terms of polymer usage. So usually, if you design a melt-blown equipment, you have to take into account one specific kind of polymer. But we try to not to focus too much on one kind of polymer, but to have the system capable to process basically all kinds of meltable polymers, to be most versatile in this regard for different products, not only one type of PP products. And of course, we do have everything what we design and invent patented by our engineers and patent department. If you look at our history and the history of our predecessors companies, we already have more than 70 melt-alone, stand-alone lines installed worldwide, using all kinds of polymers for very, very different applications. The main applications, if it comes to melt-blown, are found in the area of air and gas filtration or liquid filtration. So these are by far the most, the widest application fields for melt-blown media. But beside this, big quantity makes wipes and sorbents for insulation, for example, sound insulation materials and sorbents like oil spill materials, for example. But of course, personal protective applications such as, for example, face mask media are a big application field always already for melt-blown technology. As I said, most of the materials is made by PP, but many of these kind of materials are made from polyester and PBT as well, which is a polyester as well, and many, many other polymers, including TPU and PPS. Yes, this is
Hält gerade jemand anderes eine Präsentation.
Christian, if you can switch off your mic. Yeah. Our melt-blown technology is in general a very high production capacity technology. For example, for polyester, we can design the process to have a capacity of up to 70 kilogram per hour per production meter. In terms of PP, we can even go up to 200 kilogram per hour per meter, which is quite high and very rarely used, to be honest. But in terms of oil spill materials, this can be realized. So typical production speed is going up to 100 meters per minute for products like wipes and face masks or other filter media. But we can accelerate the speed of our forming machine to up to 200 meters per minute to, for example, allow the inline combination with spun bond, which is unwound and then combined by a calendar process. Our process is characterized by quite low energy consumption. I have to admit, energy consumption in such a process is always very high in terms of as you have to heat up air and polymer and get this air evacuated. But if you take the needed energy into account and the product quality you get for this, we can still account this technology as a quite low energy consumption technology because of the high yield. And last but not least, the few operators you need for running this line. So basically, with one or two operators, you can run the line, and you may only need another one or two operators or helpers for maintenance parts. And this will allow, all in all, a very short payback period for our customers for the plant investment. As I said earlier, our systems are designed in terms of raw material flexibility to process other polymers than PP as well. So, for example, polyester, PLA, PBT, TPU, and PPS, only to name the main polymers. We do have our own extruders included in the line, and in this regard, we can, of course, take advantage of the in-house development of the extruders and adapt the needs of the extrusion to meet exactly the requirements of the melt-blown process. Not only the extrusion technology we do have in-house, but we do have a very deep know-how in the spinning technology, not only the design, but even the development and manufacturing, which we have in-house. So, and if I say development and manufacturing, this includes the design. We do have in our manufacturing workshops the machines to produce this spherical designed melt distribution systems to ensure the high equal melt distribution, for example. And if I'm talking about the melt distribution across the widths, here you can see a cross section through our spinning beam, our melt-blown spinning beam and melt distribution system. And this spinning system comes with an integrated electrical heating. And these electrical heating elements, you see the red parts here distributed, are in a very narrow distance, which allows the manipulation of the heat profile very accurate to allow a very uniform melt flow at the end of the spinning of the melt distribution system. All this design, all this manufacturing, all these parts are CFD-based designed, and we do have two factors, not only one, which we do take into consideration by designing these elements, coat hanger for the melt distribution, for example. It's always according to equal residence time, which means to have the same residence time of the polymer if it goes directly from the center to the center, or if it goes from the center to the edges, the sides of the coat hanger. So this residence time is very important to have the same quality of the melt at the exit of the coat hanger across the whole width. And secondly, the pressure distribution across the width needs to be equal across the width as well to allow this homogeneous flow. Our systems are designed for high temperature, which means we can easily process PP, but even polyester as well, which require a higher temperature, or even PPS. So as I said, all these design requirements and this care we take in designing and manufacturing of these key components lead to the high capacity production with reduced or even no shots. Shots are always produced if the system is not capable to allow an accurate spinning. So if the spinning is disturbed at the nozzle and the melt is shooting through the system and basically shooting through the melt blown itself and creating holes. So with the design, we can more or less reduce the shots and guarantee no shot products if it needs to be very high end filter media. And of course, all the other characteristics of the melt-blown product, which are essential, as for example, high basis weight uniformity, low air permeability variation, which is when it comes to filtration media, which is a crucial factor, and last but not least, the highest filtration efficiencies you can gain with our technology. So the next part is the quenching. So it's some call it the cooling. We say it's a quenching. Basically, it's the surrounding of the spinning area by managed air to more or less make the process more independent from the surrounding environment by applying managed air to the system from the sides. If you look on the right-hand side, you can see the melt flow through the spinneret, and at the sides we apply the hot pressurized air to the system to create a kind of jet stream to create the very fine filaments at the exit of the nozzle directly. And this is a chaotic spinning process introducing hot air to the melt at a very high speed. So at the tip, we are talking about air speeds of more or less around sonic speed. So, and to make this chaotic process controlled as possible, we apply managed cooling air, let's say, to the surrounding here to keep this area under control and always under same conditions, to have at the end the melt blown media with always the same characteristics. And this is how such a system looks like. And from the spinning beam and the cooling air or quenching air system, we are coming down to a forming table, which we newly designed to be able to collect the filaments precisely here and very evenly across the width. So we do actually have a 3-segmented suction zone underneath this, the forming belt as a main suction directly under the spinning area, and 2 suction zones before and after to control the overall air stream here. This multifunctional forming head is movable in horizontal direction on the rails to always find the correct position horizontally to the nozzle, and to set the distance from the die to the collecting belt. We do have this these gear elements to adjust the height of the table and to basically set the distance from around about 120 millimeters to whatever the customer would like, up to 1 or 2 meters, which is everything is possible. Yeah. This multifunctional forming table comes with a horizontal laydown, as I just explained, with the 3 suction zones. But in the end, we do have a curved laydown area as well, where we do have a vacuum drum, which can be connected to the suction system as well. And then you can move the table with the drum underneath the spraying part to collect the filaments on a curved surface. This curved surface allows to produce fabrics with a characteristic, gradient characteristic, let's say a more closed surface on the one side and a more open surface, a higher loft surface on the other side, to produce a gradient filter media, for example, with a higher dust locking capacity. So if we now take the melt blown from the forming belt and want to increase the charging efficiency, the filtration efficiency, we are charging charging the melt blown with an electric corona charging system. This has nothing to do with the coronavirus. This is electric technology. So we are bypassing the melt blown at 4 places and applying a high charge, high electric field between needle electrodes and the rollers. And by this, the material picks up the charge and implements the charge for increasing the filtration efficiency. We have we developed 3 different stages. So combination of Tech 1, we call it. This is with the needle electrodes charging against the rollers. and we do have a wire electrode charging against a cage. So when the melt blown is, guided around these wooden rollers or insulated rollers, then we have a charged field, electric field from the wire electrode to the outside here. And this allows an even more intense charging of the material. And of course, you can go a combination of these, picking up at 2 or 3 points with the needle electrodes a charge, and at 1 point with a wire electrode. This is a very flexible and open system, and by designing an industrial solution, we decided to have this system available looking like this. So it comes very much encapsulated so that there's no chance for any operator to get very close to the electrodes. We decided to have this system capable to make 4 times Tech 1 charging, and we can apply from at each station either positive or negative charge. For some products, it's more advantage to have negative, for others positive, and sometimes even the combination on one side positive and on the other side negative charge can be advantages. So we are applying very high charging density to the material, and I think no other system is capable to produce such a high charging density to the material. And due to the flexible guiding rollers, we can charge very thin or very light white material as well as very strong material. So then we just adapt the part through this unit to allow a more gentle way and to have all materials perfectly charged according to their capabilities. Yeah, this equipment, this charging unit, EcoTech Plus, comes with all our melt-blown lines at the moment we are selling, which need to be charged, which need to be for the production of charged material, and the typical face mask media is always a charged melt-blown media. So such equipment is always part of our supply. Last but not least, our lines are equipped with the automatic automation system, let's say, to ease the operation. For example, to automatically start up the line from cold state to a standby state, or to change from one product to another product. The operator can just push the button, and then the machine levels out all the temperatures, all the settings which are needed from the one set point to the other set point. And then the green light, for example, shows the operator now the machine is in the next stage and production can be started. So this is the line, how it looks like. A single or twin beam. This is a picture of a twin beam melt-blown line. This line is 1.6 meter wide regarding the end product. So spinning width is about 1.7 meter. At the twin beam line, we can offer this as a twin beam or a single beam. For filter media production, as each beam has about a capacity of 500 to 600 tons per year. And this means for a twin beam line, we are calculating for high-end media for something around 1,000 to 1,200 tons per year productivity. But of course, if it comes to other products like wipes or sorbents, productivity can be much higher. If customers are running very precious polymers or precious additives into the system, we can provide a very fancy solution where we can turn or rotate the spinning beam and the suction box underneath the belt to adjust actually the laydown width. So to have the possibility to adjust the width, for example, from 1.7 meter spinning width to 1,240 millimeters. This is just by turning or by rotating the whole spinning beam from the rectangular position to a 45 degrees position upon the collecting belt, and so thus the material width will be going from 1700 to 1200 millimeters. And this can be done for the small lines, let's say 1.6 meter lines to the 3.2 meter lines. This system can not only rotate, it can be set inline. So if you are producing, for example, 1.6 meter, and then you want to switch to another product, and you need to go to a different width because this allows a lower edge trim, you can just push the button and say, please produce now on a smaller width, and then the whole machine turns automatically within minutes from the one width to the other set point.
Ingo, I'm sorry, I have to interrupt you now because we still have some other presentations, as you know.
Yeah. Okay.
Thank you very much to you, and also to our audience. Should you have any questions, please send the questions via the chat function. Ingo, we can chat for another minute maybe, but during this time, my colleague Barbara will start now a short inquiry for all participants. So the question maybe is now, do you already produce melt-blown nonwovens? Yes or no? This would be interesting to know how many people from you are already involved in the production of melt-blown nonwovens. So while we are waiting, Ingo, maybe just one question. We are all aware that there is a lack of melt-blown material at the moment, and the demand is very high. What are actually the delivery times for your plants at the moment?
Yeah, such plants usually can be delivered in around 9 to 12 months. But of course, at the moment, or let's say beginning of this year, when it starts to increase the request for melt-blown lines from face masks, we changed all our internal processes to make a very short delivery time possible. So, which means at the moment we are supplying from contract to startup in shorter than 5 months at the moment. So means delivery in 3 to 4 months is possible, which we do at the moment. But yeah, now we are already in a backlog situation. So in reality, we are ending up somewhere around 6 months at the moment.
Okay, thank you. And since the beginning of the shortage of the melt-blown media, to which countries have you sold your machines already?
Yeah, it's difficult to name a main region, but of course, when it started in January in China, we immediately sold some plants to China, and still we do. So Asia is now picking up after the first lines went to China, but we are selling actually worldwide. It's hard for me to tell there's a main hotspot. Of course, Europe is still, and Europe always has been a good market for us. But yeah, it's China, it's Europe, it's North America, and even other regions of the world are requesting this plant at the moment.
So sorry to interrupt you, Ingo Boris. We now have the results of our first poll, and I would like to share it with you. Just a second.
Yeah, thank you, Barbara. So 96% from our audience so far are not involved in the production of melt-blown nonwovens. So there seems to be quite a lot of potential customers, and only 4% already have melt-blown plants. Okay, maybe Barbara, you can now start the second question, please.
Yeah,
it's just 2 questions. So if you have no plants, which is the vast majority as we have seen, do you have any concrete plans to start with the production of melt-blown nonwovens? And the possible answers are yes, maybe, or no. Okay, while we are waiting again, let's continue with Ingo. we are aware that there are funding programs also, for example, here in Germany. Do you have customers taking advantage of such funding programs in Germany or maybe also in other countries?
Yes, I would say everywhere. If it comes to China and even here in Europe, we do have the German funding, Corona funding system from the economic
the
ministry.
of Economics?
Yes,
Yeah.
and as it started, of course, it is quite challenging for our customers, of potential customers, if they do have like half a year the chance from ordering to taking a line into operation. But as I said, we have been able to adjust our internal processes to make this possible, and I think quite a number of customers in Germany are taking advantage of this funding of our customers. So I wouldn't say 3 or 4 customers are taking advantage of this situation at the moment.
Okay.
Yeah.
So once again, I can present you the results of the second poll.
Okay, so 18% of the audience says yes, they have plans to start with the production of melt-blown nonwovens. Also 26% are still considering, maybe, and 56% say, well, no, that's not an alternative for us. Well, thank you very much for for your answers and for this interesting results. So thank you very much to Ingo. And now I'd like to ask Matthias Wuhlbeck to go on with the next presentation.
Thank you.
Thank you, Ingo, again. And Matthias, we know that also, of course, such protective masks require a very high level of quality to ensure the function for the user. How do you or your company, Marlow, make sure that this quality standard is actually achieved?
Yes, so thank you very much. I'm just looking how to send my screen. Can you see it?
No, at the moment we can't.
Okay. No? Not really. Sorry
Not
for
yet.
this. One moment. No, I just don't find the button where to share my screen. I'm sorry for this.
Okay, don't worry.
So is it possible now?
Yes, now we can see your desktop and the screen, but maybe you have to enlarge the presentation.
Yes, it should. It is enlarged.
Okay, yes, now we can see it. Thank you.
Okay,
so, Matthias,
okay.
You can start,
Thank
please.
you. Thank you, and sorry for this. Yeah, Marlow is a producer of online control system, and we are active worldwide. Today, we want to introduce the gauging system that we have in use in nonwoven applications, but not only there, but as well in paper, plastic, coating industry. When we think about the reason why do we need an online gauging during the production, it comes to the point that we have to ensure a certain quality level to make sure that the product in the end will provide its function. And another big point is that it is a must that we produce our product in a cost-efficient way. So in a blind flight, it is typically not possible to achieve this task, and this is why we need a gauging system. I want to show you in briefly the concept that we have, especially for the face masks today. First of all, we need to have a scanner where the sensor is able to move over the entire width of the web. And for the face mask material, we typically have a scanner called WebPro M, which is a mid-size scanner that can go up to 4,000 millimeter of web width. And here we see the scanner is moving across the width of the web back and forth and shows us the parameters of the sensors as across profiles. So when it comes to the sensors, Malo is offering a wide range of different types of sensors for basis weight using beta transmission or X-ray. Then we have moisture sensors based on infrared absorption and microwave, thickness sensors with laser triangulation and shadow thickness, air permeability, and also component sensors or ash sensors where we can directly see certain chemistry of the web. Talking about the face mask, we have two critical parameters that we need to know. Let me say, a couple of weeks ago, personally myself, I have never had such a face mask in my hand nor in my face, and I had no idea about the needs for such a face mask. And today, some weeks or months later, almost every person in the world knows about the face mask because everyone has to wear one in certain situations. So there are two very important points. First of all, the face mask must provide the protection as well for the wearer and also for the other people close by to keep away the aerosols with the coronaviruses and other viruses as well. And to ensure this function, the basis weight of the nonwoven material must be in a certain range, may not be too thin and may not be too thick. And the second important point is the comfort that we have during we are wearing this face mask. If we are under physical stress, we need to, the face mask should not restrict our breathing. Otherwise, we get exhausted very soon. So this important point is the air permeability. And the concept for face mask production range is to measure these two parameters. For the basis weight, we have several alternatives that we can use. The classic way to measure a basis weight is a beta transmission sensor. In this case, we have an emitter and a receiver. The emitter contains radioactive material, a so-called beta source, krypton-85 or strontium-90. A certain radiation is penetrating through the web. This is the web. And the residual radiation arrives at the detector. And the loss of radiation, this is the value that shows us the basis weight. This way of measurement is very common. It is in use since several decades in all kinds of industry. It needs low maintenance, is easy to calibrate, but one important point is that it needs radiation safety requirements. That means the user must have a license from its local authorities, and also a person that is called a radiation safety officer. This person is taking care in the factory for the handling of this sensor, for the safety of the operators, and so on. This slide shows how it works. So we have the source here on top of the web and the radiation beam that is penetrating the web. The measurement is very accurate and is easy to calibrate. Some customers don't want to use beta radiation, and then we have an alternative to use an X-ray transmission sensor. This works in the same way as a beta gauge, with the difference that the radiation does not come from a beta source, but from an X-ray tube. And when we have an X-ray tube, energy lower than 5 kilovolt, then the whole system is license-free. We do not need to have any officer, and we do not need any license for the government to run this type of sensor. The weight range of face mask material fits very well in the weight range of the X-ray radiation sensor. So it can be used without any problem. Other differences compared with the beta is a slightly higher cost for this type of sensor because it needs a permanent cooling, due to the fact that the tube gets warm or hot in operation. And another thing is that the weak X-ray radiation is sensitive to the component mass, and for this reason it needs more calibration and a more sophisticated calibration than the beta gauge. A third alternative for the basis weight measurement can be the infrared sensor as well. We are using a sensor containing 6 detectors that can see the components on 6 different wavelengths in the near infrared light range. This makes it possible to see the fibers like polypropylene, polyethylene, polyamide, rayon, cellulose, and several others in a certain wavelengths. So we can add the components for the total basis weight. And in addition to that, we also can see the residual moisture. And this can be a big additional benefit for the online gauging as well. Actually, there is one important limit for the infrared measurement. It does not work on black material because black does not reflect any infrared light. So this is one limit that we must consider by using infrared technology. So now it comes to the second important parameter, the air permeability. Malo is using a type of sensor that allows the measurement on the running web. Mostly air permeability is measured in with laboratory equipment. You have to cut a sample, you have to put it in the measuring device, and then you test the air permeability. And this type of sensor allows to measure this online to the running web. And the measurement is not exactly the same that you use in the laboratory, but it is compatible in a certain relationship. So with the measurement online, we also can conclude to the values that we achieve in a laboratory. The sensor creates a vacuum in his chamber, and the air is drawn through the running web. Yeah, and by using pressure sensors inside outside, we can detect the air permeability on the air speed in a range of 1 to 5,000 millimeter per second. Here we see a cross-section of our scanner type WebPro M. This contains the basis weight sensor, which can be beta gauge, X-ray, or infrared, plus the air permeability sensor here, which has a pneumatic lifting device, so it can lift off from the web when it's not operational. This is a crosscut, and this is the top view. And here we see how the sensor is moving in the cross direction over the web. And here on the right-hand side, we see the sensor placed in a parking position, which is outside the web. On the video screen, we see all important values that are of interest. This can be the actual cross profile of basis weight, of air permeability, and so on. Histograms that show the results over a certain period or length. Or here on the bottom, we see a two-dimensional, we call it a road map, which shows us in colors the high and the low values in the cross and the length direction. And the whole system is maintained with a touch screen, so there is no mouse or keyboard necessary. All data that the QualiScan gauging system is measuring are transferred via a computer interface to the main process control. This can be Profibus, Profinet, Modbus, TCP/IP, OPC, OPC-UA, so all standards that we have today in the industry. And the main process control system typically takes the active control of the process. We can have a roll report or a shift report as a printout and as a protocol on the PC, like this two-dimensional report or a cross-direction and machine direction report showing here the average cross profile of the basis weight, for instance, and here as line diagrams, the deviation of the weight over the length. So these are options that the user can use, but it is not a must. So far, a brief overview for the gauging system. I thank you very much for listening, and I am open for your questions.
Thank you, Matthias. Let's take one question. Are there any effects on the return of investments by using such online gauging systems? Maybe you can tell us something about that.
Yes, indeed. That is a quite big impact when we consider that we are able to produce our product at a low tolerance range. So we come close to the lowest tolerance range in basis weight. And this means a lot of raw material savings. We can save a couple of % of raw material. And when we think about the many tons of raw material that we use during a year, we can find out that the return of the investment for such a gauging system typically is less or even much less than 1 year.
Okay.
Another aspect is that we avoid any second-grade production or scrap production due to some wrong adjustment at the machine, because we see immediately if something with the production is wrong.
Mm-hmm. And you mentioned different sensors also. How many sensors can work in one scanner, for example?
Yes, the mid-size scanner, the Pro M, can carry 3 sensors in maximum, and we also have a bigger model, the Pro L, the large one, can even have up to 5 sensors. For example, this could be for basis weight, for residual moisture, for component measurement, for thickness, and for air permeability. So if we want to measure all these, then we can put them all together in one scanner.
Okay. Yeah, thank you, Matthias, for sharing your presentation with all of us. Now let's go forward now with Christian Gerking from the company Nanoval. Christian, you and your father, you developed a completely new approach for the spinning of melt-blown nonwovens. So we are really eager to know more about this process. Thank you, Christian. I think you have to turn on your microphone. We can't hear you at the moment.
Okay, so it's more my father and our expert, Dr. Weger. And I have been working here for 8 years now. And I worked in the nonwovens department since the beginning of my career here at Nanoval. Before I was in the food business doing evaporators and beer de-alkalization plants at the GEA. It's a big German engineering company. And the process was, let's say, started in the end of the 90s, and it looks like to be very similar to melt blown, and it's of course a kind of melt blown, but the nozzle is different. We are still the newcomer. We have plants now in the fields in the world, a production plant, but it's still under commissioning. And I would like to talk to you and explain our system. Now, so first is we're a small company, family company, and to be honest, the Corona crisis gives a lot of pressure on us. First of all, people want to have many plants in the world to prevent them to get sick due to the coronaviruses. But on the other hand, we cannot go to finalize our commissioning. So it is not easy for us because we still need to receive our acceptance certificate and also money. And many competitors which have seen that we have been dealing with this process since 20 years said, oh, this, they have never sold anything. And now we can say we have sold something. It's at least one production plant and several pilot plants. 2018 was one of the major suppliers of nonwovens in Japan. Unfortunately, we have a non-disclosure agreement, so I cannot tell you who it is. But we think we will come step by step to the market. So what is the difference? It doesn't work, just a moment. No, okay. The nozzle. You see, this is the melt here. And in the melt blown process, you have the fast gas, the sonic speed gas on the side of the melt. In our process, we have a very round shaped nozzle conically, so it is a circumferential nozzle. It's round and not linear. And the crucial factor is that we have a laminar flow and a sonic speed at the end. In the melt-blown process, you have already this set back a little bit. You have the knives maybe until this position, but it is a knife, and a knife has a very sharp edge. And this is the crucial point of a knife. And in our case, we have the highest speed at the end, and a very good momentum transfer. So we have a lower specific air consumption. We have per hole in several cases up to 15 grams per hole, but these are extraordinary cases which are not relevant in general. So we could say we have 5 grams per hole, and per meter we have to see what comes out from the commissioning. We think we have a higher throughput per meter, but you have to compare always same filter qualities. This is a high-speed picture which is indicating that something strange happens. So this is first, we have an outcome here of a big thread, and then suddenly we have lots of motion in the air, wipe effects. Years ago, we thought the polymers were splitting. We are still not sure what exactly happens, but we have a different nonwoven. As you see, there are different pictures. We go back, and they're looking totally different. And this is photographed by 50 nanoseconds. So just to show you, it is a special effect. It was not a good spinning. It was in laboratory only, because we had to make these pictures with an exposure time of 50 nanoseconds. Otherwise, it is not standstill. It is not frozen. So very different. We can regulate of course, we can improve the filter efficiency. We have reached nearly a little bit more than 98%. This diagram shows how it looks like. And one of the interesting points is that if we have a higher throughput, then the amount of smaller filaments does not reduce so much. So due to the shear forces, we have also an increase of the smaller filaments in a certain range, of course. If we double the throughput, the smaller filaments reduce. This shows some examples of our nonwovens from a pilot plant, 750 millimeter, with examples from a Chinese plant, but with a Japanese nozzle. It was a Chinese plant having a Japanese melt blown nozzle. And you see, this is the weight, the blue, the blue is the weight, and the pressure loss is the orange bars. And if we standardize the pressure loss on the weight, then we get the GRU bars. And it does not look so much different because of the diagram. So, but if you compare these gray bars with that one, you come to a reduction of pressure loss of 18 or 30%. So I have in mind 8 millibar compared to 11 millibar of the standard melt blown pressure loss for something like 97 or 98% efficiency BFE test, Nelson test. But this was from a pilot plant and not from our first production plant, as I said. So we are not that ready now. So this is the small plant which we sold to Japan. It shows the nozzles. So they are circumferentially shaped. There's the Laval nozzle. And the melt nozzle is inside. So like if you have the small mechanical pencils, and we have a higher throughput. And so we do not need so many holes. But a consequence of the higher throughput is that we have a lower air consumption, a specific lower air consumption. So this is the spin wheel we sold to China, and which is still under commissioning. So last year we started with the commissioning. We had a severe problem with the leakage, but we are fast engineers. We solve this problem, and now it's tight. And we have a very nice throughput. Now we have to tackle the commissioning, and this can be done when our expert, Dr. Weger, can go to China. Yeah, at the moment it is too risky. So that's how the spinning looks like. You see, this is a very even system. When you start the clean system, the polymer comes out from all individual nozzles at the same time. So it shows that the distribution with respect to the residence time is very even. It's a very good distribution and a very good spinning. But we have to solve the problem of the laying. That's where we come from. With the same nozzle principle, we atomize every day in Berlin metal melds to powder. We have also a process which has been adopted to refractory metals such as tungsten. And tomorrow we will atomize, for example, niobium. And I think in the next days also some other things like tantalum or tungsten again. So we have our system is very stable for different processes. As Dr. Mellmann said from Oerlikon, also our process is robust for various polymers. And we can also spin cellulose. Cellulose is a solution spun process, which is very, let's say, good for the environment, because you can use trees or simple cellulose products instead of cotton. But you need a very high investment for the large recovery units for the solvent. So cellulose spinning, lyocell spinning is only something for big companies. But my father, who's getting old in these days, he is not so much in the office anymore. He was very fond of cellulose. He said it's the raw material of the future. Now, when coal was that of the 19th century and oil was the raw material of the 20th century, cellulose will be the raw material of the 21st century. And probably he's right. But it needs some time so that the people are willing to pay for it, because, of course, it is more expensive to spin cellulose. And cellulose is, as far as I know, the only material which is biodegradable and from natural origin. So the PLA is not really biodegradable. It is only composed in an industrial composting, and you need steam or heat, excess heat. This year we received a patent also for the fully flushable nonwoven. But the topic of fully flushable or flushability is not one of the filtration market, and not anymore. It is already solved with the special yarns and special fibers. So these are our spin beam. At the moment, we can only supply a spin beam, and we can only tell you that we are confident to reach the highest standard of 98 and also 99% bacteria filtration, or FFP2 quality according to German standard. But we are not in the position to demonstrate, to show you a plant which is running. We are sorry, we have only a plant in the laboratory scale in Germany, and we can also not deliver a complete line. So we would need, if you need a plant from us, complete line, then we have some partners which we can start a cooperation. This we can offer to you. Okay, that's it.
Thank you, Christian, for your presentation. Maybe one question from my side. What is the most important advantage of your technology compared to Meld-blown nonwovens?
So although our technology is not so much different, it's also a melt and also a very fast air, which is going to spin the polymer. We have a totally different structure. our non-woven materials are stronger, they have more higher elongation, and they show a different tendency with respect to softness and with respect to air permeability. So we have a lower pressure loss, and it's a complete new green field. So the melt blown is a fantastic system, but we have a new vector. You know, it is a new, let's say it's a new possibility to optimize. So maybe it comes out that none of our products will be good for that application and melt blown for that application. We don't know at the moment. But what we have seen, they are stronger, have more elongation and a lower air permeability. But it has to be found out in future by product developers. We are producing the piano. Other people have to play on it.
Okay. Thank you. That's a nice picture. So let's cross the fingers that you will be able to install the plant in China you mentioned, and that your new technology, your new approach will become a springing tiger, as you mentioned it in your title.
We hope so.
Thank you. Yes, thank you. Thank you, Christian. Okay, now let's come to the Q&A session. As we said before, we have received a lot of questions from our participants from all over the world. Hope you can see my screen at the moment. Nico, can you see my screen?
Yes,
Yeah,
I can see it. Yes.
Okay. So then, Nico, you have you are on the stage now.
Okay.
What kind of questions have you received, and maybe you can forward them to our experts from the companies.
So first of all, to answer some practical questions, some of the participants asked about the contact details and about the presentations. Of course, you will receive the presentations after the webinar, and the presentations include, of course, the contact details of our experts. So we start with a question for Mr. Melman for Oerlikon. How long does the electric charge in a mask last? Can you answer this question, Ingo? We can't hear you.
So again, that's a very good question. Thank you for this. It's a little bit difficult to answer though. So it depends very much. Electric charge, which you apply to a polypropylene non-woven, how long will it last? Depends pretty much on the polymer, on additives, and on the charge intensity. And last but not least, it depends pretty much on the how you store the material. So if you have a good storage, dry and cool, then the charge will stay much longer than, for example, if it's moisture and warm around the non-woven. So then the discharge will happen very quickly. So I cannot really answer this question precisely, but there are some factors being positive in terms of keeping the charge for a longer time, and some are very negative. Yeah.
Okay, another question is, what are the applications for standalone melt blown lines?
It's a good question as well. So there's so many different applications. For melt blown lines, as I said in my slides, the main field is maybe the filtration field. So air filters are there are a lot of different kinds of air filters for all kind of applications. Liquid filters, if it comes to fuel filters, water filters, or even blood filter media can be produced on melt blown. Wipes can be produced if it comes for disinfection wipes, for example, or other cleaning wipes. And insulation materials, oil spill wipes, oil absorbers. And the versatility of such a plant. So only thinking of TPU, for example, which is a very nice super elastic polymer, can be produced via melt blown directly into applications like apparel. So elastic apparels, second skin, something like this. All this is possible, and always on the same kind of platform.
Okay. And from the same question, person is the question: does Oerlikon has a lab-sized melt plant for academic institutes?
Yes and no. We do, of course, we do have a lab line in our facilities, and of course we can provide such equipment to institutes as well. So we can, as we do have the design, we can provide such equipment to academic institutes as well, for sure. Yes.
Okay. So there are some other questions about the prices for the Oerlikon and nanoval technology. I would suggest that the persons who want to know the price contact the gentleman afterwards via email and do the bargaining face to face, or maybe at the next ITMA fair in Italy, in Milan. So another question here is, how far can you reduce the grammage of the melt blown without falling below 98% bacterial filter performance?
How far can you reduce or reuse?
Yeah, how far can you reduce the grammage of the melt blown without falling below 98% bacterial filter performance?
98. Usually this material is around 25 to 20 GSM. And if you go lower and for this BFE2 material, then we are still in the area of 99%. So for 89%, probably even lower. But you have to take into consideration stability of the filter media itself, and of course the filtration efficiency. So there has to be something. So I cannot really answer because we did not trial this. How far can you go down for 98, 89%? It's more customers are asking how high can you reach efficiencies at a low basis weight? So what is the minimum basis weight to reach BFE2 standards? And this is, I would say, around 20 GSM.
Okay. Another question for you, Ingo. Does Oerlikon sell the charging unit as a separate machine?
Yes.
Okay. Clear answer. Thanks. Now a question for nanoval. Is nanoval ready for installation in different countries, for example, India?
Yes.
Okay. Clear answer.
Sorry?
A clear answer, thanks.
Yes.
Short and simple.
Only for the spin beam. Yeah? So we have for the partners, if we have to organize a complete line, then we have to rely on the partners. But for example, these partners could be Indian partners, yeah, from India, so no problem. But for us, it's no problem to go to India. I have been to India in '88 already, when I was a student. For traveling.
Okay. Then there is a question that's again for Oerlikon. Is melt blown used in HEPA filters, HEPA filters? I'm not a technician.
Yes.
So.
Yes. Melt blown can be used in HEPA filters. Yes.
Okay. Okay. Thank you. Then there is another question. Is nanoval's commercial production ready for lab facility only?
No, the commercial product is ready. We have sold one commercial product, 1.60 meters, but it has not been commissioned yet, finally. So it is ready. We can sell, and we are confident to reach FFP2 quality. But unfortunately, at the moment, we are on the wrong foot. We cannot demonstrate.
Okay, thank you. So that was it for the moment with the question. So I encourage the participants to... Yes, a new question is coming. Does Oerlikon provide lab setup or just for industry?
No, both. So we can provide lab equipment as well as industry scale equipment. At the moment, we sell more industry equipment, but our job as an engineering company is to design to the requests of our customers, and if the customers are requesting lab scale equipment, we can provide lab scale equipment as well, of course. Our own lab equipment is 550 millimeter spinning wheels. So from this on and even smaller, we can provide equipment.
Okay, another question. Is there any possibility to integration between Marlow and Oerlikon for controlling the properties of the web automatically, for example, by adjusting the spinning speed and air quenching?
Yeah, we do have usually in our lines integrated Marlow scanning system. A Marlow scanning system with online basis weight and air permeability measurement. So to provide our customers an inline quality control system, as Mr. Wolbeck outlined. So, but we are at the moment to have a system which allows a closed loop between the signal from the Marlow air permeability system to have a direct influence on the settings at the line, so that the line can adjust itself to keep the same product characteristics, or to even switch from one product to the other product by programming or giving the characteristics from the control system, and then the system is changing automatically in a controlled way to the next setting without the operator's influence. So to have a kind of industrial 4.0 machine which is adjusting itself. So to have, and this is including the Marlow system.
Another question, in a single extruder, how many polymer can we run?
All these kind of extruders. So from TPU to PPS, PP, PBT, it's basically all be running through one extruder. Well, but not simultaneously, of course.
Another question for you, Ingo. Does a 20 GSM melt blow sustain winding, or do you need to use a carrier?
No, 20 GSM is possible to wind, yeah, without carrier.
Okay, another question. What BFE is possible by using 20 GSM melt blown without electrical charging?
I would say BFE 1. Yeah. BFE 2 would be difficult without charging. Then we have to look if the basis weight will not go too high, which means at a certain stage, the pressure drop is getting too high. So BFE 2 needs to be below 40 Pascal pressure drop to have the breathability. And of course, you can reach the filtration efficiencies by putting up the basis weight, but then you lose the pressure drop criteria.
Okay, that was it with the questions. So there are no questions coming in anymore. Just a moment. One more question. How much the scrap percentage at the startup end of production?
It's difficult to answer. Depends on the experience of the operators. Depends on the polymer, of course. It's not so easy to answer on
Okay. So. Okay, then I would suggest that I switch over to Boris.
Thank you, Nico, and thank you also to our audience asking these questions, and to the company speakers from the 3 VDMA members. Now I'd like to ask my colleague Christine Schmidt. Christine will give you an overview about all the technology suppliers, or at least VDMA member technology suppliers in the entire value chain.
of mask production. So Christine, the stage is yours.
Thank you, Boris, and thank you for listening also to my speech. As Boris said, I give you a short overview and start, of course, with the topic of today, the production of surgical masks, particle filtering half masks, as you heard already, the production of the textile material is the first step. The mask production follows as a second step. And in today's web talk, you heard a lot about the production of the nonwovens material. As you can see here, there are more VDMA members which offer technology for this first step. And apart from the nonwovens, you will need, or the wearer of the mask will need an elastic band to wear the mask. There are several technologies available for the production of such bands. They can be braided as a stranded or round braid on a head soak braiding machine. And Kamaya has developed a solution for producing elastic tapes on warp knitting machine. And last but not least, Lucas offers circular knitting machines for the production of such elastic bands. A short introduction on technologies for fully fashioned textile community masks. These masks are at the moment no medical products, no personal protection equipment. But the advantage is that these masks are produced in one step, including the ear bands, without sewing. And you can see two pictures as examples. One is warp knitted from Kamaya, and the other one below is a woven one-piece mask woven on Donier loom or weaving machine. As I said, these masks can be produced without sewing. Only cutting out is required. And yes, fully fashioned, that means knitted or woven in the mask form in which they come off the machine. And partly there can be an integrated pocket for an additional filter insert. And the big advantage is that the filter can be replaced and the mask can be washed and used again. So the last slide is on technologies for the production of alternative textile materials with a filter effect and the textile finishing. Also, masks produced with those technologies require two steps, so production of textile material and the production of the mask. These technologies are suitable for the production of community masks as well, and with non-woven insert as a surgical mask. We have as the basis the production of the fabric suitable fabrics with a high density. They can be warp knitted or woven on broad or narrow weaving machines. Then we have machines for layering to further increase the filter effect. We have machines for special finishing of the inside or outside of the mask to make it hydrophobic or hydrophilic, or to treat the fabric so that it will be, it can inactivate bacteria and viruses. And of course, we have the machines for the production of the elastic bands. And we have a member company offering software systems for the quality assurance of mask production. So for all steps of the mask production. This is all which I can provide you in 5 minutes. I thank you for attention. And in case of special questions, you can contact me directly. And of course, also our sourcing service at Machines for Textiles is at your disposal. Thank you very much.
Thank you, Christine. So now we are already almost at the end. I hope you can all see my screen now. As Christine has mentioned, there are of course other kind of masks, and our second webinar will have the focus on production technologies for fully fashioned textile community masks. This webinar will take place mid of July, and of course we will also send you the invitation. Let me thank now also the speakers for today's webinar, and also I would like to thank all our participants for staying with us. You will get 2 mails from us probably today. The first general mail from GoToWebinar about the so that you can give us a feedback about the webinar. And secondly, we will also try to send you the company presentations by email today. And these company presentations, of course, include the contact details of the speakers. So whenever you have further questions or whenever you want to get in touch with these companies, you have the contact details then. Well, I already mentioned the webinar. If you have any other questions regarding other kind of technologies, as Christine has mentioned, just contact us. You can also find my contact details here. We thank you very much for your attention and for joining us in this webinar, and we hope to see you soon in our next webinar or on one of the exhibitions. Have a good day and stay healthy. Thank you.